Thank you for joining us today. This is Consuelo Ortiz from Wi-Fi Alliance, and I'm here to talk about updates to Wi-Fi QoS Management. COVID's impact to workplace around the globe forced leaders to leverage technologies to keep people connected under the new normal. This created an unprecedented growth of real-time bidirectional communication applications over Wi-Fi, both at home and enterprise networks. An enterprise user expects to run a video conference without pixelation on PowerPoint slides or garbled voices independent of the network. And likewise, a user of a mobile gaming application anticipates enjoying a smooth gameplay without lag time or jitter. Because these real-time communication applications cannot tolerate large degrees of traffic, jitter, or traffic loss, they increase the need to further evolve Wi-Fi QoS techniques. To address this need, Wi-Fi Alliance has continued to advance technologies that improve the Wi-Fi experience with real-time applications. Our first step towards QoS came with Wi-Fi certified WMM, a technology that is now widely adopted. But still, the QoS treatment between wired and wireless networks were not always aligned by default. And we have seen inconsistencies across the industry on how DSCP markings are mapped to user priorities. So in 2020, we released the first set of Wi-Fi QoS management features. And this year, we have added new ones. Wi-Fi certified QoS management provides mechanisms to ensure a robust service delivery and higher quality experiences with latency-sensitive applications. With Wi-Fi QoS management, you can prevent low-priority traffic from monopolizing link bandwidth and affecting high-priority traffic, such as voice. Wi-Fi QoS management works with all Wi-Fi generations. It benefits automotive, enterprise, public, and residential networks. So consistent QoS treatment is critical for low latency applications. And in general, applications on client devices have the best knowledge of QoS requirement for individual IP flows. But in some cases, the network does, in order to support mission-critical enterprise services. In addition, the desired QoS treatment of individual IP flows might not align with overall network objectives for efficiency and fairness. This is why Wi-Fi QoS management support both client and network-centric negotiated QoS setup and maintenance, where both entities can initiate and express the requirements. Client-centric features. So there are use cases in residential and guest networks where there may not be DSCP markings for ingress flows coming from the public internet. Wi-Fi QoS management provides a way for the client and application to get the AP to match flows to the right QoS treatments. And we have features to do so. So rather than having the complexity for the client to figure out IP templates to make the request, we introduced the mirroring mechanism, MSCS, defined in RevMD, whereby the application on the client device sends flows in the app link with priorities that use the right access categories and user priority. The AP then mirrors back in the downlink the corresponding IP flows, flipping source and destination, so you can have bidirectional QoS based on what the client wanted. A Stream Classification Service, SCS, is conceptually similar to MSCS. It is also initiated by the client device, and the AP applies downlink user priority assignments. It differs from MSCS because each user priority assignment rule is individually requested and managed. The client needs to determine the IP tuple classifier for each IP flow and include it in the request to the AP. SES supports modification and teardown of rules of individual IP flows, and also exceptions that enable to treat individually child SAs in IPsec to support the 3GPP 5G use case. So to address DSCP mapping inconsistencies and to reconcile the marking recommendations offered by both IETF and IEEE, Wi-Fi QoS Management adopted IETF RFC 8325 as the default mapping from DSCP to Wi-Fi user priorities. RFC 8325 is widely recognized by the industry, and it represents an agreement on how this should be done. Additionally, the program adds the QoS map feature, which enables administrators to configure non-default mapping tables on client devices and APs when they need to. This feature can be used to change the prioritization of flows and allow the mapping of non-standard DSCP values to be specified, all under the control of the network administrator. DSCP policy feature allows finer-grained QoS management of uplink flows. It enables an AP to request a client device to apply DSCP markings to a specific uplink traffic flows, which are identified by a classifier based on IP tuple, port range, and/or destination domain name. The DSCP policy feature can be used in conjunction with QoS map, where DSCP policy specifies the DSCP marking rules and QoS map provides the mapping from DSCP marking to user priority. For example, it enables configuration of policies that cause IP flows that would otherwise be marked with the same DSCP value to instead be marked with different DSCP values and therefore assigned to different user priorities. It can be used in combination of group policy and mobile device management tools for dynamic policy management on managed client devices and can also be used with unmanaged client devices in guest or public networks. Wi-Fi QoS Management improves the user experience in a large variety of use cases. For example, XR services and gaming, hybrid workplace applications, consistent treatments when traversing Wi-Fi and 5G networks, prioritizing mission-critical applications like collaboration, onboarding, training, and automotive applications. In summary, Wi-Fi QoS Management enables Wi-Fi devices, applications, and network managers to prioritize traffic flows. This is to ensure time-sensitive traffic receives higher priority, greater bandwidth, and less delay than best effort traffic, enabling more efficient sharing of network resources to expedite the handling of mission-critical applications, provide low latency, high reliability KPIs for gaming, XR services, and metaverse, and deliver consistent QoS treatments to 5G cellular traffic with Wi-Fi access network. Thank you for listening to this overview. For additional questions, please contact me at cortiz@y-fi.org. Thank you.